Okay, this is going to be part 2 of our fundamental hyperbolic trig function identity series. Wow, that was a mouthful. And you can see the two that we're going to talk about here today already on the blackboard. I'm not going to derive them so much as, well, I can prove them. I'm going to prove them, but I'm also going to talk about why they make sense. And what I'm going to do first is just remind you of, I guess this was probably college algebra for most people. Anyway, it's algebra. That when a function is odd, you test that whether a function is odd, because you know that if you take the negative argument of it and you end up with the negative of the function, that means it's odd. And you probably also then remember that if you take the negative argument of it and you end up with the positive function, then it's even. Well, the reason that these identities, let's say, make sense, because of course everything in mathematics makes sense, but the reason that we can think of them and think, oh yes, I remember why this is this way, is because we just need to look at their graphs and then we can understand. Sine h is odd. It's symmetrical about the origin, right? It looks like this, kind of, sort of. And the hyperbolic cosine function is even. It's symmetrical about the y-axis. It looks something like this. So it makes sense that these identities hold true. Now we're going to prove them because it's not very hard to prove them. We're going to start with hyperbolic sine. And because we know that hyperbolic sine is e to the x minus e to the negative x over 2, right? We're just gonna make those x's negative, which makes this negative and this positive, right? Well, what we end up with is negative e to the x plus e to the negative x over 2. Well, if you look at this and you look at think about what our original was, we really just have to factor out that negative, and then we have our original function, right? So we're going to just factor that out, that negative right here, and we're going to have e to the x minus e to the negative x over 2. And this is our hyperbolic sine function. This is hyperbolic sine x with a negative in front. And that is how we proved that this identity is true. Now we're going to do the same thing with hyperbolic cosine x. We're gonna just look at what the original was. The original hyperbolic cosine is just e to the x plus e to the negative x over 2. Well, if we make those x's negative, again, we end up with a positive here, and we end up with a negative there, and a positive x here. And now what do? Well, we rearrange e to the x plus e to the negative x is just what we have here, right? We're just switching them around like we did over here, over 2. Well, that's just hyperbolic cosine. That's just hyperbolic cosine x. It's the exact same thing, right? This is just hyperbolic cosine x. So we have proven that hyperbolic cosine of negative x is just hyperbolic cosine x. So this identity is also true.